This is our 45th lesson on the biblical flood. I'm Marion Fox, and we're looking at some dealings with the age or the speed of light and things that are used to date the age of the Earth. We'll be looking at that in more detail. The claim that the speed of light is constant is used to prove the universe is several billion years old. The claim is that we're seeing light from stars that are billions of light years away. Now, a light year is not time. A light year is the distance that light would travel in 1 year if the speed of light is known to be roughly 186,000 miles per second, or 3 times 10 to the 8th million meters per second. So the claim that the speed of light is constant is used to prove the universe is several billion years old. Remember that. Hubble's law and the age of the universe. We'll be looking at that as well. And then we'll look at problems with the Big Bang theory. And then we'll look at other problems with Hubble's law. And we answer the question, would God be deceptive to create things full grown? Now, this is one of the claims made by atheists. So we'll be looking at that in some detail here, okay? Now, there are modern day scientists who are questioning the claim the speed of light is a constant. Now, we showed last week that there are things called gravitational lenses. So when light goes near a star, the light is refracted. Now, refraction is the bending of the light path for the light due to the change in the velocity of the medium through which the light travels. Light goes through a prism and it separates out the various colors because the different colors will have their speed, their velocity change a different amount. So they'll come out. That's why a rainbow occurs after a rain. And what we get is the space itself is apparently being warped or somehow misshaped so that it changes the speed of light as the light is traveling near a star or some large object, such as a neutron star or even a star like the sun. And these are called gravitational lenses. They've known about them for quite some time. What that shows is that space itself can be changed so as to change the speed of light. And we dealt with that a little bit last week. The speed of light, some have claimed that it has been slowing down, that it was almost infinite in speed and at the creation, and it began to decay exponentially at an exponential rate. And Bethel, and of course, you have the book, so it's cited here. Bethel is cited, and so their question, the claim that it has been constant for all time. Some of the arguments against the constant speed of light have been published in the journal entitled Galilean Electrodynamics, but we'll not look at it in much more detail. If they're right, however, the light could have reached the Earth in a much shorter time span than the present light. And it would make perfectly good sense that God would create it that way. Now, let me point out, my background is electrical engineering, and then I took electrical physics with lasers, did graduate work in lasers and semiconductor physics. That would be the manufacture of semiconductors or transistors, chips manufacturing. I did some work in that. But what we get into is with light, it could have reached the Earth in a much shorter time than the present. In my study of it, I found that there's no evidence that light would have to have been the constant speed. some electrical circuits can be made quite readily, and there are a number of apparatus that can be made that would have a decay, an exponential decay of the, for instance, voltage on the circuit to decay exponentially down to some constant value and hold that constant value after it reached that point. And this certainly, they can make circuits to do that and apparatuses to do that. So it's entirely feasible that God could have done it. Now, why would God have done it that way? So that the light could have reached the Earth very quickly and function to be a guidance for time or measurement for time, as it's stated in Genesis 1. But we'll get to that a little bit later. The Schaeffer points out that there's no ancient light to be measured compared to present-day light. Remember, they have to view it to be able to be true science. It has to be empirical. And so our problem is they don't have ancient light to compare to present-day light. If it indeed begin at a high velocity and then decay down to some constant value, then this would explain what we see. In 1924, and that was before I was born, fellas, I wasn't alive at that time, Edwin Hubble set forth his law, which states that the velocity of a galaxy moving away from the Earth is proportional to its distance from the Earth. In algebraic terms, Hubble's law is v, the velocity of the galaxy, is h, Hubble's constant, times the distance, where v is the velocity. And so d is the distance the galaxy is from the Earth. Now, the Hubble's constant is not precisely known. There's a range of values probably, but Hubble's constant is not known, and it's based on assumptions of the constancy of the speed of light. So it could be way off compared to that. And so this assumes that the speed of light is constant. Now, a parsec here is noted here. 1 parsec, he mentions, is defined as a distance as which the radius of the Earth's orbit around the sun would subtend 1 second of arc. An arc, an angle, is usually measured in degrees. We measure in degrees there. In advanced math, they'd be measured in radians, but let's just talk degrees. Most people understand them. They're 360 degrees in a circle because the Chaldeans had a solar measurement apparatus called a sundial that had 360 days in it. So they had 360 days in their year. They had a base 60 number system, not base 10 like we have. And so they divided each of those days up into 60 minutes or 60 degrees, 360 degrees. Each one divided up into 60 minutes. Each degree was. And then each minute was divided up into 60 seconds. Again, this was a base 60 system. So 1 parsec is defined as the distance radius the Earth's orbit around the sun would subtend 1 second of arc. That's 1/60th of, that's 1/360th of a degree. And so we could work it out. That would be 360 degrees times 60. That would be how many minutes of arc you had. And each minute of arc on the equator of the Earth is a nautical mile, incidentally, as a side point. And then you'd have 60 of those multiplied by 60 again. That's how many parsecs you would have on the Earth as you circle the sun. This is circling the sun. And it's numerically about 3.26 light years, 1 second of arc. When a star is moving away from the observer, it will lengthen the wavelength of the light coming from the star, shifting the light toward the red part of the spectrum. Now, the red part of the spectrum is a lower wavelength light, and that means the light has a different energy level to give different colors. The blue end of the spectrum is a shorter wavelength light. Ultraviolet light is a shorter wavelength even than blue as it goes into the ultraviolet light. And eventually that turns into X-rays as the wavelength gets shorter and shorter. Finally, it goes to gamma rays, which are even shorter wavelength. These are all electromagnetic waves. So the light shifts toward the red part of the spectrum as it's moving away from the Earth. This is thought to occur. It's assumed to be occur because of what we call the Doppler effect. Now, the effect, you can observe it by standing beside a highway and listen to a car coming toward the observer and then move away. A motorcycle, particularly a motorcycle that runs at a high RPM, it may come toward you as it moves away. You can hear that. Or a car coming, you can hear it not quite as much, but it's not as pronounced. But if you have a real high RPM engine, like a motorcycle, a small motorcycle, you can hear it quite well, or a car that has a high RPM engine. And that's what we hear. We're hearing the Doppler effect. As it comes toward us, the pitch goes up, and then as it passes us, goes away from us, the pitch goes down, and that's like the redshift, right? As it moves away. My sound effects are not very good. Sorry about that. Here's the Doppler effect. I pulled this off the NASA Research Center. And of course, what we see here, it's moving. If it's moving in this direction, it catches up with some of the sound waves and it shortens the wavelength, so the pitch goes up. And on the other side of it is moving away from it, and so the pitch goes down. And so you hear the high pitch coming toward you, and then as it gets away from you. And this is some of the equations for it. We won't go into the Doppler effect. It's a very well-known system. It is, I believe, the Doppler effect is well established in science, and so I don't question it at all. But that's the claim, that the Doppler effect is actually the explanation for the redshift that occurs in the light. Now, the reason they know it's redshift is because each element has a certain spectrum of light it gives off. And so if an object is giving off one color of light and it moves away from the observer, the pitch or the frequency of the light, the frequency will go down and the wavelength goes up. And we usually talk about the wavelength of light. In RF signals, we usually talk about the frequency, but they're related to each other with the philosophy. Here is a link that explains the Doppler effect, and you can take this link and type it in and find it. Or you can just type on Google, just type Doppler effect and see a number of sites that illustrate the Doppler effect. So there are many websites on the internet that discuss the Doppler effect. Now, notice whether this is called redshift, it assumes the phenomenon results from the Doppler effect. And again, we've already stated you can stand beside a highway and listen to a car come toward you, then move away, you can hear the change in the pitch. As the sound from the car rises as the car approaches and then lowers after the car passes the observer as it moves away. And the speed of the car didn't change. So if the speed of light is not constant, it might also explain the phenomenon known as redshift, which Hubble used to date the age of the universe. If space itself is somehow stretched out, as the Bible speaks of, God stretches forth the heavens, and we showed a number of passages that say that. If space is stretched like it is, we know it can be stretched due to gravitational lenses. That's proof that it can be stretched. If it is stretched, then this would explain the redshift quite readily. It could explain it if the speed of light was variable and changed. Now, redshift that is usually explained by the Doppler effect could be explained by the decreasing velocity of the light as well. It could be explained by that as it changes. And this is linked to the Hubble constant calculation of the speed of the universe that claim that the universe is expanding. And of course, this gets back to the claim that it's formed by the Big Bang, but we'll look at that in a little more detail later. Now, ARP and Valkowski and others give evidence for non-Hubble redshift. In other words, redshift can occur from other means, by other processes. And so that can occur. And I find it very interesting. What we see primarily is redshift in most stars, which means that everything is traveling away from us if the Hubble's law is correct, which means that we're near the center of the universe. That would be most interesting, that we would be near the center of the universe. ARP has an extensive discussion in his article about non-Hubble redshift. They give other reasons for non-Hubble redshift other than a changing velocity of light. So there's other things that could explain the non-Hubble redshift other than the change in velocity of the speed of light. So what we have is there's a bunch of things that could occur that cause this redshift to occur. Keep that in mind. Use of redshift in Hubble's law assumes the universe has a beginning, a point from which the galaxies are moving. That's an assumption. It basically assumes that the Big Bang formed the universe, that it was created and formed that way. The beginning of the universe is usually called the Big Bang. It assumes the universe began at one point, therefore it had a beginning. Now we're going to look at this in a little more detail. There are only two options here. Either matter is eternal or matter was created by someone or by something. Now that's the only options. Now if we say matter is not eternal, then we have to say it had a beginning somewhere, something created it or someone created it. That would be the only logical options. Eternality of matter violates both the first law of thermodynamics, which is a very fundamental law of physics and engineering. And it's not, that law is not questioned except whenever we get into the creation of the universe. They want to say the law doesn't work there, but we'll get to that in just a minute. The second law of thermodynamics is also violated, and the principle of entropy. Now, we won't spend time delving into these in great detail because of the time factors, but the second law of thermodynamics and the first law are very fundamental laws, and I really don't know of any scientist other than for the Big Bang that question these laws and the principle of entropy. Entropy in country boy terms, or very simple terms, would be that everything's wearing out or things are running down. Engineers would define it this way, that the amount of usable energy is decreasing with time. And so we can't use energy. Entropy would say that eventually the universe will die a heat death. That is, everything will be very, very cold, and all the energy will be dispersed equally throughout the universe. And at that point, it has the heat death, the universe does. Some scientists have claimed that the second law of thermodynamics does not apply to the universe. And again, we get into a change in their problem with their thinking, because there's a principle of uniformity that's usually assumed by scientists, which says the laws of science apply throughout the whole universe. And there's uniformity of these laws. And that's an assumption that's used by scientists. And it's a violation of one of these most fundamental laws of science, principle of uniformity, or the principle of science. And it's not just the law of physics, the laws of thermodynamics, and the principle of entropy, but these fundamental principles and laws. Second law of thermodynamics does not apply the claim that it doesn't apply to the Big Bang is an implicit rejection of the principle of uniformity. That is, it's a claim that in time, at least in time, the laws of science, the laws of physics don't apply. And so we have the creation of something from nothing. The atheist is guilty of the fallacy of special pleading. And in other words, he will want to throw away the laws of physics for the Big Bang, but he's not willing to set them aside for a miracle occurring. And Jesus walking on the water or something to that effect. When he sets aside the second law of thermodynamics for the Big Bang, but disallows it for the miraculous creation by God, then he, of course, has been guilty of this logical fallacy of special pleading. Basically, as I explained it here, he applies two sets of rules. He applies one to himself and one to some other separate set of rules to other people, and one for the atheist and one for the Christian. So he has two sets of rules for him. Doesn't apply the rules equally. And of course, that's an unfair way of looking at things. If the universe did not begin as a single point with infinite mass, the Big Bang, but was created full grown, the age calculated by Hubble's law is older than the universe. So if it was created full grown, now it would make perfectly good sense if it was created full grown, as we've already set forth. Humphreys, I believe he's a creationist. He explains redshift by another means. Humphreys, and I cite Humphreys' book, he theorized that God created the universe by means of a white hole, which began to expand. White hole is basically the inverse or the opposite of a black hole. A black hole is sucking everything into it and getting more massive, and a white hole that's coming out of it, and the matter is coming out of the white hole. That's what he theorizes, that that white hole began to expand. The edges of the white hole would effectively make the measurement of time from distant stars to be impossible. And so that's the claim, and he theorizes this. I think it's plausible he might be right. But again, we're dealing with theories here, and there's no science to back it up because you can't empirically look at it. And we have to ask ourselves, are we going to take what the scriptures say, or are we going to take the theories that have not been substantiated? Now, the white hole would allow for creation to occur, and it would be a physical thing as well. But also explain redshift. This would explain redshift as well. Now, his theory is derived from Einstein's general theory of relativity, which there seems to be some credibility to that theory. There are two theories of relativity. We won't get into it with the special theory and the general theory. We're talking about the general theory of relativity. The theory set forth by Humphreys seems to be quite plausible, although it's possible that some of his interpretations of passages of scripture are incorrect. I looked at his book and I think he's misinterpreted some passages of scripture to justify his claim. One argument for the Big Bang is that the distant galaxies are traveling faster than the near galaxies, according to what we can see. This is what one expects from an explosion. The distant objects travel faster than the near objects. That happens when an explosion occurs. Wolfson and Paskov, this is a general physics book generally designed for the university level, more rigorous than what most colleges would have. They state in their book, in 1929, the American astronomer Edwin Hubble, after him the space telescope was named, found that spectral lines, see, there's a spectrum of light from every object, from every element, and from distant galaxies were shifted toward the red end of the spectrum, with the shift proportional into their distances. This is exactly what one would expect from a colossal explosion that had flung them apart. That's Wilson and Pascal. Now, of course, if we see the redshift, that could be explained by explosion. These differences in velocity of the galaxies, or apparent differences, could also be explained by a change in the velocity of light. Changes would be greatest for the distant objects, making them appear to travel faster. Support of the Big Bang theory from this point is based upon the logical fallacy. Now, here's their argument. It is based upon a logical fallacy of affirming the consequent. Therefore, it proves absolutely nothing. Here's the basic argument. The first premise is if the Big Bang occurred, then the furthest object should be traveling faster than the nearest object. I agree with that premise. That's true. The furthest objects should be traveling faster than the nearest objects as they occurred. They should be traveling faster than the nearest objects. And so they're claiming they are traveling faster than the nearest objects. And the conclusion is the Big Bang occurred, but notice what they've done. They have affirmed the consequent rather than affirming and they could deny the consequent and it would be a valid argument. But to affirm the consequent and claim the antecedent is true is certainly a false claim. That's logically irrational. The argument basically is if the Big Bang occurred, then we should see objects moving faster. Then objects will be moving faster than the distant objects will be moving faster than the nearer objects. And the farther objects, distant objects are moving faster. Therefore, the Big Bang occurred. Let's see. It sounds good, but it's irrational from the standpoint of logic. It really doesn't prove anything. First problem with the Big Bang is that scientists, and there's a bunch of problems with it, have not found enough mass in the universe to cause the Big Bang according to all of their models. So there's not enough mass in the universe. And it's not just 10% off, it's way off. It's by a factor of 7 to 1 or something or thereabouts. We then add up, here's a quote, total mass of all the galaxies in the cluster, that's a star cluster, a cluster of stars, and compare it to the amount of mass we know must be present to counterbalance the observed velocity dispersion. So if we look at how fast they're moving apart, and of course using our information or measurements, observation of the light, then they say that there has to be a certain amount of mass in that galaxy or in that cluster inside the galaxy. We know that there's a certain amount of mass that must be present. The result is astonishing. This is Morgan. There is by a factor of 7 too little mass in the galaxies to counteract the tendency for the cluster to disperse. And it would tend to disperse unless gravity was pulling it back. But see, he says we don't have enough mass, and it should be dispersing faster. This area is not trivial. Since the coma cluster, and that's to talk about the coma cluster, has not yet dispersed for every 7 kilograms of mass we feel must be in the cluster, we can account for only 1 kilogram in the form of galaxies. In other words, there's not enough mass out there that we found that for this model to work. Science cannot find this matter. So they can't find it, so what do they argue? They argue that there must be something called dark matter. We can't see it. So there's a new kind of matter we don't know about that's causing this to occur. That's what their claim is. They have to theorize a new kind of matter, dark matter. This dark matter, is necessary for the occurrence of the Big Bang. So we assume the Big Bang occurred. The matter has to be there. It's just dark matter. We just can't see it. And so we have a problem with it. Theist knows that God created by fiat, and that means by his divine power. Genesis 1:1, again, God created the heavens and the earth. So God created all of that we see, the heavens and the earth, in the beginning. He did it by his power. The problem with the Big Bang is cannot account for the heavier elements. The Big Bang could have formed some of your lighter elements up through carbon. And of course, the lightest element is hydrogen and then helium and so forth up the spectrum. You get up to carbon, and you can't form with your processes. You can't form the heavier elements, and so there's a problem here. The Big Bang theory of the origin of the universe believed to account for the formation of most of the matter in nature, as well as its observed abundances. That is, 98% of all matter known to be hydrogen and helium. These are the two most prevalent forms of matter, hydrogen and helium. However, Big Bang theory accounts for little of the nature's diversity. He tells us that is the 2% comprising the elements from carbon to uranium. Viola tells us. Now, what we can't see is, let's just pick some element like copper. There's no way our models of the system would explain the presence of copper, how it came into being. We can go on up iron, nickel, and cobalt, and just right on up. As an element gets heavier, we can't have less and less ability to explain where it came from, how it got here. This failure of the Big Bang theory to explain the facts doesn't seem to bother the atheists. Why? Well, because the only alternative to his theory is to accept creation by a being that it would have to be God, an omniscient and omnipotent being. This problem is also discussed in a book edited by Prontzos and Van Giel Juan, pages 407 to 408. With the atheistic worldview, now that's how they view the whole universe. The atheistic scientist has a system which he admits cannot explain the facts, but he won't modify his system to conform to the facts as is normally done by scientists. So he has a lot of problems with his theory. It's just theory. It's not science because he can't observe it. Why do they not revise their hypothesis? Why? Well, because the only alternative is creation by a creator, and capital C for creator, which they refuse to accept. Let's look at Romans 1:28. And even as they refused to have God in their knowledge, God gave them up unto a reprobate mind to do those things which are not fitting. So we see our society turning more and more to things that are not fitting, they're not proper, and they're laid out for us in Romans chapter 1:28 and following. Materialism, I believe, is a form of idolatry that states mankind was created by natural forces and non-living matter. Nature itself created us. Oh, nature didn't create us. Father God created us. Third problem with the Big Bang is that it requires that different laws of physics were in place during that part of the Big Bang. And we have to reject the principle of uniformity. Wolfson and Parsec state present-day physics cannot address times before 10 to the minus 43rd seconds, which requires a merging of quantum theory and general relativity. So you just can't explain it. And this, of course, talking about the Big Bang, of course. This amounts to an implicit denial of the principle of methodological uniformitarianism or uniformity. Principle of uniformity is what we talked about. We discussed this on page 8 of the book. Gould, Stephen J. Gould, defines methodological uniformitarianism as uniformity that asserts the invariability of natural laws in space and time. Well, Gould is correct. That's what it is. And by that, we define this the principle of uniformity. And we have the principle of uniformity here as a basic assumption of scientists. The inconsistency, the scientists are inconsistent, and their inconsistency is evident in that he sets aside the laws of physics for the Big Bang, but cannot allow it to be set aside at other times. Now, the fourth problem with the Big Bang is that it should have created magnetic monopoles. Mono is one, and so magnets, the magnets that we see normally have two poles, the north and south pole. But this would have to form magnetic monopoles. Magnetic monopole is an isolated north or south magnetic pole. Magnetic north pole without an associated magnetic south pole. A magnetic south pole without a magnetic north pole. That's what we should see out there if the Big Bang occurred, but they haven't found any. Now, Wolfson and Parsec discuss these. They state the theories of elementary particles suggest that magnetic monopoles should have been created in the Big Bang event with which the universe began. So they claim it began with the Big Bang, and they should have created magnetic monopoles. No one has yet found a magnetic monopole, however, although serious experimental searches continue. My point is they haven't found them. That doesn't mean they don't occur. I understand that. That would be, of course, the fallacy of making an assumption, and it would be the fallacy of denying the antecedent. If they found them, then they exist. They haven't found them, therefore they don't exist. Now, that's a bad argument. I'm not making that argument. I'm just pointing out that they need to find some magnetic monopoles to get some credibility. And they haven't found them yet. Doesn't mean they don't exist. I understand that. There are a number of serious problems, not other than what we've mentioned here, but the Big Bang cosmology. Cosmology has how things were formed. Maddox, on pages 16 through 18 of his treatise, he lists a total of 7 problems with the Big Bang cosmology. And in addition, Lindy lists 6 objections to the Big Bang cosmology. Some of his objections are not in the 7 of Maddox, so he lists some more. Some of the objections listed by Lindy are different from those of Maddox. Yet more than 7 objections, close to 10 objections. In order to be credible, the Big Bang theory, the advocates of the Big Bang theory need to validate, they need to solve these problems, all of these problems, because their system has lost credibility due to that. Can't explain them. It's just a theory, and without answers to these problems, perhaps others to be discovered will remain an unproven theory, is all it is. An unproven theory. Remember, science is empirical, and most of these principles and points here can be verified by observation, by empirical means. Hubbles constant is assumed to be 50 kilometers per second per 10 to the 6 parsecs. 10 to the 6 would be a million parsecs. From this, 10 to the 6 is 1 with 6 zeros after it. From this value, assume that redshift is due to the Doppler effect. The age of the universe is calculated to be about 19.5 billion years old. But again, it's based on assumptions. Astronomy, and this is not as highbrow as some of the other journals that I'm citing. This treatise here says some astronomers say it's about 15 kilometers per second per million light years, while others claim it's higher. And now they're talking about Hubble's constant, 23 kilometers per second per million light years. These 2 studies provide yet another answer, about 11 kilometers per second per million light years. From that, we got 15, 23, and 11 at different values. The value of the Hubble constant implies that the universe could be 25 billion years old, according to Astronomy magazine, page 222 of the site that I cited. What we're finding out is the value of Hubble's constant is far from being settled. Teams of cosmologists continue to argue back and forth about the numerical value of the Hubble constant when Cohen. Now, I understand if you take the widest range of these values, it still would put the universe in the billions of years old. So and of course, it's based on the assumption of the constancy of the speed of light and some other assumptions that can't be proven. All of these calculations based on assumption the universe began from a single point with infinite mass. The Big Bang theory is true. That's the assumption that's made. In fact, astronomers disagree on the value of Hubble's constant H, and we see a change in the speed of light would affect it if the speed of light was changing. So they disagree on it. The value of the distance used in Hubble's law is not known with any degree of confidence either. Now, we have another quote here. Without question, one of the greatest challenges in astrophysics is the attempt to derive reliable distances to objects in the universe. In what is commonly known as the distance ladder, there exist steps which allow us to estimate distances sequentially from nearby stars to distant galaxies. So they take it to one star and then they project it up to another universe, another galaxy. And so we go from one galaxy to another and make this assumption. But Tyson says, in the interest of honesty, however, the distance ladder might better be termed the distance house of cards, because the reliability of each level depends critically upon the reliability of the previous, presumably more secure level. So you make an assumption that your readings here are correct, and then you use that to calculate the next set of readings. What if the first one was bad? Everything following it's bad. We have a house of cards here. It just will collapse. The type of reasoning that we see here is not uncommon. Calculation of the age of things by atheistic scientists. We will lay this out in further lessons. God would only be deceptive, and is full-grown creation deceptive? It would be deceptive to argue it. Well, God would only be deceptive if he created things full-grown and then attempted to convince mankind these things were older than they really were. But he didn't do that. He told mankind where mankind came from, and he being mankind, came from, and who created him, and all the things that man sees. Adam was told that he was created and that everything around him was created by God. Adam was told about the creation and the fact that God created it for mankind, Genesis 1:26-31. We won't read that. That you read it for yourself. It only appears old to one who does not believe that what God said in Genesis chapters 1 and 2 about the creation. It appears to be old. And if I might summarize it here, we have laid out here some problems with the Big Bang theory and Hubble's constant. All of this gets into the question of the age of the universe, or age of the solar system at least. And we'll be looking at that in more detail. Hope this has been helpful to you. I know we went fairly rapidly through it. Do you have any questions?